Hello everyone, it's Mr. Rops.
And Miss Weaver.
And we are here today about function notation. And there's no calculators allowed today. We're going to talk about function notation because it is so handy because you get to deal with things like that, what we're going to deal with here. So, Miss Weaver, I have two equations.
Can tell what time we're doing this at.
Time for school to start. So we got two equations here, y equals x squared plus 3x minus 5 and x squared minus 2x plus 1. Could you find me y when x is 2?
Yes, but I'm a little confused right now because there's y on the left-hand side of the screen and y on the right-hand side of the screen.
And so which one was I talking about? It's hard to tell. So what mathematicians have done, and they're so clever, they've introduced a new kind of notation. They call, as opposed to calling it y and having it confusing, they call it maybe the function f of x. This is all one notation, is x squared plus 3x minus 5. And they might name this one g of x squared minus 2x plus 1. And all this basically means is the g of x is the y value for some value of x. And this is, f is also the y value. So now if I said to you, could you find me x or could you find me f when x is 2? Which one would I go to?
Right, okay.
I would go to this one then.
So can we use, is it just f and g? Or
We could use whatever letter we want to. We can use
I'm going to use
H,
w all of the time.
W. I like to use R, any kind of scenario that we want. And if these letters are x's, then this is an x. If it happens to be t's, then it's a t. All right, and so basically an f of x, which is the most common one, simply means the y value. All right, so let's try an example. So if f of x is this equation, then find f at 2, is how we say that. What does this mean?
Okay, so I am going to use the f of x equation given, and then the x value has to be 2.
So that,
Because I can see that the 2 is in the same place as the x in the notation.
right, and so x is 2, and the whole calculation when I'm done will be what the y value would be. And so when I have f at 2, I'm going to plug in 2 for all my x's. So f at 2 is simply 2 squared plus 3 times 2 minus 5, which is then just doing the arithmetic, ends up being 5. And this is what f at 2 is. So what's the y value when x is 2?
Yeah, can we write our final answer down there too so we can see everything together?
Like that?
Yeah.
Perfect. Nice. And so this says when x is 2, the y value is 5. So I can even think of it as a coordinate point, 2, 5. All right, let's try another one. So now we have all these functions. We have f, we have g, we have h, and we have all kinds of different problems here. So the first one says f at 2. So which function am I going to use for this one? What am I going to do, Miss Weaver?
I think you might use the f of x equation.
Woohoo! All right, so go ahead. What am I going to write here?
X squared plus 3,
Mm-hmm.
but we're looking for f when x is 2, so it will be 2 squared plus 3.
And then I get 4 plus 3, which is 7. And so I know f at 2 equals 7.
Or we have the coordinate point 2, 7.
Nice. Excellent. All right, I'll switch to blue now. And we'll do h of x. And when I do h of x, I'm dealing with this one here. And so h at 6 will be 1/2. My x value is 6, so I'll plug it in. Minus 4. Now remember when we're doing our fractions, we simplify first, divide each by 2 before we multiply. And then I'm going to multiply the 1 times 3 minus 4, and I get -1.
Oh man, it's been a long summer.
It has been a long summer. And so the coordinate point here is 6, -1. All it's saying is that the y value is -1 when x is 6. And it's a handy notation. Okay, moving on to g at negative 3. Well, here's my x value. I'll plug it in to 2 times the negative 3 over, I'll get negative 3 squared minus 3. I do the arithmetic on here. I get negative 6 on top.
Oh, we have to be careful on the
Right.
denominator.
Negative 3 squared means negative 3 times negative 3, which is 9. Positive 9 minus 3, which will be negative 6 over 6. I can do that one. That's just negative 1. And so g at negative 3 is negative 1.
I think the next one looks very fun.
Oh.
There are some letters, there are some numbers.
Nice.
What is going on there?
Oh, it's just good fun. It is fun all around. All right, so let's try. So this is our x value.
Okay, we can do that.
All right, so what am I going to write?
So I'm using the h of x function,
Right.
but my x value is 1 minus t.
Okay, so that's going to be 1/2, and opposed to the x, I replace in 1 minus t
Okay.
minus 4.
That didn't hurt so bad.
No, not so bad. Now, I have to distribute the 1/2. I get 1/2 minus 1/2 t, subtract 4 more.
Oh, and we can simplify that one more.
Right, we have like terms here, here. So if I go through all my lovely math steps with my fractions, I go 1/2 minus 1/2 t. My denominator, I'm going to make this 8 over 2. 2 is my denominator. And then negative 1/2 t. I like to put that up front. 1/2 minus 8 halves is negative 7 halves. And this is the value of h at 1 minus t, is this.
That was pretty fun.
Not too bad. It was good. I like that one. Okay, so now we have one more to do. We have f. Let me get rid of some space. All right, so f now. Again, we have letters to play with. And we have letters. We're going to put it into here.
So our x value is now 2m.
Okay, super. So that's my x value. So wherever I see an x, I write my 2m, so it's 2m squared.
Now, let's pause for a second. What might a good math student who's had a really long summer accidentally write there that would be incorrect?
I'm going to guess they would say that.
And let's take one more step and see how those are different.
Okay, so here's the incorrect way. So I go 2m squared plus 3, and that's done. The correct way, when I do it in parentheses, I'm going to square everything. And so the 2 gets squared, the m gets squared, so 2 squared is 4, m squared, and then plus 3. This one is wrong. Everything is squared. The whole x value gets squared.
So let's make sure we don't fall into that trap.
Exactly. All right, I think we have one more example to go through. All right, so now here is question 3. We have f of x is this lovely function. For what value or values of x is f of x equal to 7? What does this mean, Miss Weaver? I'm not so sure.
Well, if I fall into the trap of just going along with patterns, and I don't read carefully, I'm going to substitute 7 in for x, but I don't think this is what this question is asking.
Right. So, So I think this is saying the y value is 7, not the x value this time.
Okay, so let's actually write that other notation so we can see how they're different.
Like this notation, you mean?
Yes, and the opposite question. So the opposite question
would be f at 7
equals what?
What?
So that's not what we're looking for. We're asking a different question that time. So let's get rid of that.
That's what we did in question 2. We're not doing it this time. This is the y value. So I want to know, when does this function, x squared minus 6x, equal 7? Oh, now you have to remember from last year your quadratics. When you are solving quadratics, you let one side equal 0. And so we subtract 7. And then we have to factor this thing. And now,
Factor. There is a word I
Factor.
have not used much this summer.
No, me neither. Factors when we end up with these brackets here and 0. And if you remember, we did the x and we multiplied the two outside together to get negative 7x squared. We looked at the negative 6x here. And we asked ourselves, what two values multiply to get negative 7x squared and add to get negative 6? You're on the spot now, Ms. Weaver. What's that going to be?
Negative 7 and positive 1.
Okay. And then we went to the box. But when we did the box, I always knew it was these two values, the negative 7 and the 1, that ended up being here. So it's x minus 7 and an x plus 1. And so we can skip the box on these simple ones. We haven't got x yet because I know that x minus 7 could be 0 or x plus 1 could be 0. And so then simply x is negative 1 and x is 7. So there's our values for this solution. And so I know one coordinate point would be negative 1, 7, because here's the 7, and the other one would be 7, 7. Great. All right, welcome back, everyone, and I'm looking forward to the rest of the year.